Okay, I'm really excited to share with everyone something I've been working on. It is a technique that I'm calling the layered node contrast analysis. It's kind of a mouthful. Maybe an easier way to think of it would be as an evidence ladder. And what I'm doing is I'm beginning with a decision tree, but I'm using the decision tree not to estimate value or to find comps. Those are ways that decision trees are already used regularly in the appraisal profession. Decision trees are a major part of quite a few AVMs. But I'm actually not interested in directly predicting value from a decision tree. But what I am interested in doing is using the structure of a decision tree to sort of mine our data to see what we can learn about our market. And in particular, what we can learn about feature differences and how the market reacts. So the concept is really no different than a grouped pair. We've all done grouped pair analysis before. I'm assuming that is something that pretty much every seasoned appraiser has used many times. So the concept is very familiar. But what we're doing with this type of analysis is we're doing that at scale. And the way we're doing that is by comparing nodes in a decision tree. So I'm going to stop talking about it like a decision tree because it's really not the flow of what we're doing. We're actually just using that type of tree structure to isolate variables. So if we look at this tree, we have different layers, and we're splitting a particular variable into groups to isolate a variable. And so what we're doing is the contrast is between two nodes. What's the essentially like the median indication of value in this node and the difference in this node. And the nodes are selected because they're identical in all but the one variable that we're studying. And so, what differences can we extract from those nodes? Now, in the day and age in which we're living, we have the the ability to model for more complexity and computational rigor that we didn't really have many years ago. And so, what we can do is we can do these grouped pair analyses on every node in this tree. And the trees get very large when we're talking about the number of variables and maybe a large data set. So I want to show you what this looks like in practice. So let me switch to this screen here. Let me move myself over a little bit. So this is again, this is a layered node contrast analysis applications. This is an application that I've been building and working on, and I want to show you what it does. So essentially, I'm dropping in a data set, mapping out some variables. I could even model for some variables if they're things that are maybe too small to have its own tree. Um, uh, and then what's really important here is correlation, because what we're doing with the tree, the whole idea of the tree, is that we are trying to control for correlation. So uh, if you think back to the last time you did a grouped pair analysis, the result probably wasn't the adjustment. And the reason is because the result was probably bundling in other correlated features. So for instance, I see this all the time. If I have done and a grouped pair analysis for pools versus no pools in a given market segment. And the result is if I don't filter for anything else or control for anything else, if I'm just saying, okay, give me every sale in this neighborhood, I'm going to separate them into two buckets and then look at the price differential. The price differential is going to reflect correlated elements. So perhaps the typical home with a pool has a larger lot. than the typical home without a pool. Maybe the average pool home's larger. Maybe it's got more likely to have a third car garage, some other correlated elements. So that differential in price is really telling me uh, it's telling me pools plus all these other things. And so what we are looking at, and the reason that sort of like an evidence ladder is a good framing for this, is we can look at every variable and we can see the ladders. And so what are we looking at on the screen here? Let me kind of zoom in here. Um, so let's see, we're looking at pools right here. Maybe that was too far to zoom. Uh, Here we go. So this is exactly what I was just saying, is we want to try to look at pools for a given market. So in these box plots, every point that you see is actually a contrast. It's a node to node contrast in the tree on that layer. So each layer is going to try to uh, solve for, control for other variables. Now, in this particular case, this data set had very low levels of correlation uh, with anything else that I was studying, any other variables that I'm including in this data set. So it didn't really change the output from layer to layer. You do see that the layers get a little messier. Well, that's because as we're controlling for more and more, we're actually getting lots more contrasts. In this particular case, there wasn't that many more contrasts because there weren't that many pools in this data set. But what you're when you're controlling, you're essentially having smaller and smaller buckets of data. So there's going to be more chances for things that I didn't control for to wildly swing some of the contrast. So that's why you see the whiskers on this get really wide as I get down to my deepest layer. So this is the most controlled layer. So I've isolated the most out of all my variables that I'm including here, but I've also gotten small. Each node contains a very small set of sales at that point, and so things that I haven't modeled, or sorry, haven't controlled for, important variables like quality and condition that I didn't structure for this data set, they're going to impact some of those contrasts. So you'll see you have a point really high, a point really low. Well, that's because those contrasts were completely overtaken by some other factor. So really what I'm looking for is where's the central core of all of the contrasts. And in this particular case, the central core was fairly consistent. It dropped in the second layer, but most of the layers were around $25,000 from this data set. That's really helpful. Now, for me, in my practice, that can help to inform ranges, because I'm using this to help support and inform ranges in adjustments, uh, because with the thing that I've been talking about, the holistic adjustment technique, I don't need to support a specific adjustment. I only need to have a supported range, and that range can actually be fairly broad, because the holistic adjustment technique is going to test um, everything within that range. So what I think of this as is a solution space prediction engine. So if you're familiar, if you've watched my videos on the holistic adjustment technique, you heard me talk a lot about a solution space and how to sample within it. So when I conceived of this as a method, it was really a method for, well, how would I, if for somebody without, maybe without domain experience, maybe a reviewer, they don't know anything about my market at all. would there be something that would help uh, to sift through, maybe a larger data set and help to, uh, to support some of uh, those adjustment ranges. So these are just use cases, but in terms of just studying a market, how do people behave? This is immensely helpful, and it's really taking our existing paired sales, grouped pairs, and this is the next level. So this layered node contrast analysis is just scaling up the technique that we already have in a way that we can in the era where our data keeps getting better and our ability to analyze that data through technological tools keeps getting better. So I hope that this has piqued your interest in this technique, and let me know what you think. Layered node contrast analysis, horrible name, but really helpful technique.